It's Thursday. Today we're going to talk about adding, subtracting, multiplying, dividing, and reducing radicals. We actually already did this in class, but I don't remember which day it was, and I'm not 100% certain everyone was in class that day or that everyone actually got the concept. So we're going to go ahead and talk about reducing radicals, and I'm going to try my best to do this in one take and make it less than 10 minutes. All right, so first things first, given a radical, you can do two methods. You can either know perfect squares or break it down. Hopefully you know that 16 is a perfect square, so square root of 16 is 4. Otherwise, 16 is 4 times 4. You're looking for pairs of size 2. I have two 4s, therefore my answer is 4. Okay, 24. Okay, you could do a factor tree, or you could break it down into perfect squares that you know. So I know that 24 is 4 times 6. So that is root 4 times root 6. Well, I know that root 4 is a perfect square, so square root of 4 is 2. It becomes an outside number, so root 4 is just 2, and then root 6 stays the same. Or you could have done root 24 is 2 times 12, 12 is 2 times 6, and 6 is 2 times 3. Looking for pairs of size 2, there's a pair of 2's here. I could take out a 2. And then these guys don't have pairs, so they would be multiplied and taken back inside. So either way you do it is 2 root 6. Okay, root 45, again, if you can think of perfect squares, it makes your life easier. So instead of doing the factor tree or whatever, I would just go, oh, well, 45 is root 9 times root 5. I know square root of 9 is a perfect square. That is 3. And then root 5 does not reduce. So 3 root 5 is my answer. Okay, 2 root 108. So 2 ways to do this. Again, you could do the factor tree or just break it down. I guess I'll go ahead and do it both ways for this guy. So if you're doing factor tree, that is 2 and 54. 54 is 2 and 27. 27 is 3 and 9. 9 is 3 and 3. Looking for groups of size 2. I can take out a pair of 2's and a pair of 3's. Don't forget I've got that 2 up here. So this 2 is coming down here, this 2, and this 3. And this guy is solo on the inside, so he's just stuck as is. So he goes back on the inside. And then 2 times 2 is 4 times 3 is 12. Okay, doing it the other way, 2 root 108. Well, if you break down your perfect squares, if you go down the list and try 4, 9, 16, 25, 36, etc., then you end up with 2, that guy there. Root 108 is root 36 times root 3. I just broke 108 down to 2 squares, one perfect square and just one number. And then, of course, square root of 36 is 6. So 2 times 6 is 12, root 3. So same answer either way. Do it how you want to. All right, and very last one, we're just going to do factor tree because I don't actually know this answer off the top of my head. So it is even, so I know I can cut it in half, so half of that's 171. And then this guy happens to be 9 and 19. 9 is 3 and 3. 19's prime, 2's prime. This is a pair of 3's. So bring down your negative 9. Bring down your pair of 3's. Everything else who does not have a partner has to go back inside, and 2 times 19 is 38. Okay, negative 9 times 3, negative 27, root 38. So next we'll talk about adding and subtracting radicals, and the rule for that is you can only add them if the inside of the radical is exactly the same. So root 3 and root 48 are obviously not the same. So reduce radicals, and then if you have similar radicands, then go for it. So root 48 is, well, I'm going to bring that 2 down. Root 48 is root 16 times root 3. Root 16 is 4. 2 times 4 is 8. Root 3. Bring down this guy. 5 root 3 plus 8 root 3 is 13 root 3. Okay, subtracting, exact same deal. Again, I cannot add these guys as they are. Root 96, root 24, not the same, but go ahead and break each of those down. I'm bring down my 4 there. Root 96 is root 16 times root 6. And then there's a minus 5. Root 24 is root 4 times root 6. And then we can already go ahead and see they're going to have the same radicand there. But root 16 is 4. So now it's an outside number, so 4 times 4 is 16 root 6. Root 4 is 2. 5 times 2 is a 10, but it's a negative, so it's negative 10 root 6. And then you just add or subtract the outside numbers. So 16 minus 10, I now have 6 root 6 left over. All right, so now I'm going to slow down a little bit. For the next month, we're going to talk about multiplying and dividing radicals. And the rule for this, I think I went over in class, but I'm not certain, is outside, outside, inside, inside. Also, my voice is raspy because it's now midnight. But anyway, outside, outside, inside, inside, literally just multiply the outside numbers together. 3 times 5 is 15. Inside numbers, 2 times 10 is root 20. And then once you've done that, always try to reduce further if possible. Root 20 is root 4 times root 5. Root 4 is 2, which is now an outside number, so 15 times 2 is 30. Root 5, that's kind of illegible there. Okay, moving on over. Still outside, outside, inside, inside. So when you multiply this straight through and distribute it, 4 is an outside number and 5 is an inside number, so you can't do anything with them. So literally just push 4 on the outside and 5 on the inside. Okay, multiplying over here. The outside numbers are 1 and negative 1, so it's just a negative. And then 5 times 20 is root 100. And then square root of 100, hopefully you know, is 10. So we have 4 root 5 minus 10. Normally, if you were taking an EOC, you would see negative 10 plus 4 root 5. Okay, and then one last one. So let's multiply this guy straight through. So 2 root 3 times 2 root 12. Outside, outside, inside, inside. 2 and 2 are both outside numbers, so that is a 4 on the outside. Inside, 3 and 12. 3 times 12 is 36. So those 4 looking items become just 2 because they're 2 outsides and 2 insides. Then multiplying this guy straight through here, outside numbers are 2 and a negative 1, so it's just a negative 2 on the outside. Inside is 3 and 5. 3 times 5 is 15. And then again, try to reduce and maybe you could add them together or whatever. But root 36 is a perfect square. He is a 6. So now he's an outside number. So 4 times 6 is 24. And this guy can't reduce any because 15 is just 3 times 5. So you're stuck there. All right, last two problems here are division, and you follow the exact same rules again. Outside, outside, inside, inside. A couple different tricks on these though. Sometimes actually dividing straight down. So I'm going to show you kind of the wrong way to do this, and then I'll show you kind of the easier way. So if you're just doing outside, outside, inside, inside, 2 divided by 4 is 1/2. And then square root of 8 divided by square root of 16. Well, 8 goes into 16 2 times, so you'd have square root of 2 on the bottom. We actually are going to learn in a couple weeks how to rationalize that. So you actually can't solve that currently because we don't know how. So what you want to do is go back to your original problem, and if you ever have a perfect square, take care of that instead. So I am going to do outside, outside, inside, inside, but I'm first going to take care of the fact that root 16 is a 4. Okay, and I'm also going to reduce root 8 just as is. So I'm going to end up with 2 root 8 over 16. Now I don't really actually have any inside stuff, but I still need to reduce this guy here. You could reduce 2 and 16 right now, but I'll just do it at the end. So root 8 is root 4 times root 2 over 16. Square root of 4 is a 2. So on the outside upstairs, I have 2 times 2, which is 4. Root 2 over 16. And then I'm still going to do outside, outside, inside, inside. So 4 over 16 is 1/4. And then root 2 has nobody to reduce with downstairs, so he's just stuck. So I'm going to change this guy into a root 2. And I'll go ahead and we got a minute to spare, I guess. I'll go ahead and rationalize real quick. Maybe this lesson can be done in a second. Rationalizing, you literally take whatever is wrong with the bottom, which is always the radical, and you multiply top and bottom by that number. So multiply by root 2 and root 2, because root 2 over root 2 is a 1, and you can multiply any equation or whatever by a 1 and not change it. So then multiplying straight across the top, outside and inside, I just can't do anything, so kind of just push them together. And then down here, outside is a 2, inside is a 4, but square root of 4 is a 2, so you end up with root 2 over 4 as well. So either way you do it, you get the same answer, but we're not going to rationalize. That's just a free lesson right there. All right, cool. Very last problem, and then we are done, and you will have Delta Math homework. You'll be doing 4 problems from each category. All right, this is my problem. I have just a dividing radicals, and I can do outside, outside, inside, inside. Outside, outside is 1 and 1. Inside, inside. 15 divided by 3 is a 5, but it's inside, and there's your answer, root 5. All right, I know I went a little bit fast. I started recording this video at like 11 o'clock, and I did not do it in one take. These videos take forever, so I apologize. I just want to get through in like about 10 minutes. So I'm going to call it quits here and go ahead and do that Delta Math, and I will see you guys tomorrow.